again, had to pause the video because I had an error. This, I don't know why, but it always starts acting weird whenever I go back, and try to run through everything again. It was doing that earlier too. Anyways, here's the output for that. And as we can see, the interaction term between IQ and race is again not significant, indicating that homogeneity of regression slopes is met. If the interaction term were significant, I would run a robust ANCOVA. So now I'm going to go into reporting the results. So whenever you report the results, it's going to be similar to a regular ANOVA, but we have to report the effect of the covariate as well, which I didn't actually have here. But for the purposes of the write-up and everything, I'll just pretend like I did. For the covariate and experimental effect, we have to give the details of the F ratio, including the degrees of freedom, which is calculated by dividing the mean squares for the effect by the mean squares of the residual. However, it's in the output. And then the degrees of freedom used here are for the effect of the model and the residuals of the model for the covariate and the IV. Partial eta squared differs from eta squared, our effect size measure, in that it doesn't deal with the proportion of total variance that a variable explains, but rather the proportion of variance that the variable explains that's not explained by other variables in the analysis. So going in a little bit more into effect size. The package that Andy used in the book to calculate partial eta squared is no longer compatible with R. So I went online and found a different package to use after some searching. I think it's DSR, something like that Andy's packages. You have to create a variable called T that contains the T values from the ANCOVA output, specify the degrees of freedom, which in my case would be 195. The equation for that is total sample size, which mine was 200, minus P, which is number of predictors, which in my case is 4, and then minus 1, which means the degrees of freedom would be 195. But anyways, again, I used a totally different package here. So let me attach that, or upload that, get it loaded in. With my syntax, I'm printing the effect sizes for the ANCOVA model by placing the variables within the eta squared function. So I'm specifying the model here as an object within the syntax, the sum of squares type here, and then this is going to determine whether or not I want the entire ANOVA output. So if I were to put true here, then it would give me the output that I saw earlier. So I'm going to run that. And as we can see, the partial eta squared for IQ, the covariate, is practically non-existent, which makes total sense considering that there was really no effect, no significant relationship there. However, the partial eta squared for race is roughly 0.2, which indicates a large effect of race on performance on the selection measure. So all in all, race significantly predicted performance or had a main effect of performance, but the covariate of IQ was not significant, and we would definitely have a problem with this selection measure if we were to use it in real life.